For this one, we have x to the 2/7 times x to the 3/4, 14th, sorry, not fourths. All right. What do you do when you have like bases and you are multiplying? What do you do with the exponents? You add them. So you're going to say x to the 2/7 plus 3/14. When I am adding fractions, what is my number one rule of adding fractions? You must have. Yeah, like denominators. So common denominator here is 14. This 2/7 is going to become 4/14. Right? Common denominator. 4/14 plus 3/14 is 7/14. We want to reduce that, x to the 1/2. If I say leave it in exponent form, this is exponent form. If I say leave in simplest radical form would look like that. Remember, x to the 1/2 and the square root of x are the same thing. Those are the same thing. All right, so for number 67, we have x to the 3/5 divided by x to the 1/10. I am dividing like bases. What do I do with my exponents? Subtract. So 3/5 minus 1/10. Again, same rule applies here. I have to have common denominators, which is going to be 10. So this 3/5 becomes 6/10. 6/10 minus 1/10 is 5/10, and it is the same exact answer, x to the 1/2 or square root of x. Last one, 71. So number 71, I have an entire group. I have 16x to the 14th over 81 y to the 18th, all right? And that whole thing is raised to the 1/2. So what I'm going to do here is I'm going to take everything on the inside and raise it to the 1/2. 16 to the 1/2. X to the 14th. Well, we'll do that on the outside. X to the 14th to the 1/2. On the bottom, we have 81 to the 1/2 and y to the 18th to the 1/2, all right? To the 1/2 just means square root, right? So what is the square root of 16? Yeah, so this guy is going to become 4. When I have a power to a power, what do I do with those? You multiply them. 14 times 1/2 is 7, all right? 81 to the 1/2, that is square root. What's the square root of 81? 9. Power to a power, I'm going to multiply. 18 times 1/2 is 9, y to the 9th. That is my answer there. If I could reduce the 4 and the 9, I would do that. I can't. If there had been like an x on top and an x on bottom, you would have simplified that as well. But at this point, it is as simple as it can get. All right, solving radical equations. Just like it sounds, a radical equation is an equation that has a radical in it. They're very creative in their name, right? Radical equation. All right, a radical equation has a variable and a radicand, or has a variable with a rational exponent. So basically, in order to be considered a radical equation, the variable has to be affected by the radical. Meaning the variable has to be in the radical, or the variable has to be to a fractional exponent, which is basically just a radical written in exponential form. All right? And so our whole goal here is to get rid of the radical, or to get rid of the fractional exponent. And so we are going to do that by the methods that we've been using other places. Look at this first example. Just like anything else, when you're solving, you want to get it by itself. So if I'm looking at this, I have the square root of 3x minus 2 in a radical, right? Square root. And so I really want to get rid of everything that is not in the radical first, so that I can then deal with the radical itself. So when I'm looking at something like this, the first thing I'm going to do is I'm going to subtract that 2 from both sides, so that I have this radical by itself. Square root of 3x minus 2 on this side, 4 on that side. So I want to get the radical by itself. And then now that I've done that, I want to get rid of the radical. So the way you do this is you use the index. So if I have something to the 1/2 and I want to make it to a whole, number, I want to make it to the numerator there. So I am going to raise it to the reciprocal, 2. All right, raise it to the reciprocal. And that's going to make it just an x. So if I have a square root and I raise it to a square, it's just going to get rid of the root. That's all that's going to happen there. And so when I have a square root in my radical, I'm going to square both sides. It's an equation. All right, and so I'm going to take the left side to get rid of this square root. I am going to square it. Because I squared the left side, I also have to square the right side. Square both sides. All right, on the left-hand side, the square and the square root cancel each other out, and I have just the 3x minus 2. On the right side, I literally just do the numeric evaluation. 4 squared, that's going to be 16, right? Then I have a really simple equation to solve. Add 2 to both sides. 3x equals 18. Divide by 3, x equals 6, all right? Now, I will say there are situations where you have extraneous solutions, all right? We're going to get to some of those. So these are ones you probably want to check, especially if you have a variable on the outside as well. That's where you're going to see some extraneous solutions. So to check it, you do it exactly like you do any other equation. You plug it back in and solve. All right, you plug it back in and solve. In a case like this, your answer is likely not going to be extraneous because your variable was on the inside. It's when you have variables also on the outside that it potentially causes issues with extraneous solutions, all right? But to check it, you would just plug it in and solve. So go ahead and try check understanding 1 at the bottom of that page. So fractional exponent, we have this group to a fractional power, all right? And so we definitely want to get rid of that. And so we are going to do that by isolating the group and then using the reciprocal of that power to get rid of it, all right? And so we are going to first divide by 2 here. So I'm going to take this whole thing and I'm going to divide both sides by 2. On the left-hand side, I'm left with just that group to the 2/3. On the right-hand side, I simply divide, all right? Now I need to get rid of that 2/3, all right? So I am going to raise both sides to the reciprocal power. So I'm going to take this side and raise it to the 3/2. Because I did that, I'm going to raise this side to the 3/2 as well. Why do I do that? Well, what happens when you multiply reciprocals? I have a power to a power, so I'm multiplying them, right? I'm multiplying these guys. And what happens when you multiply reciprocals? What is it? Always. It's always 1. Yeah, it's to the first power. And so anything to the first power is just itself. So these basically cancel because it's to the first power, and I have just the x minus 2. Then how do we deal with this guy? You want to look at it as a radical because it's going to be easier in this case. Remember, this is my index, the square root of 25, right? And I don't really need that there, but just writing it. Cubed. What is the square root of 25? Cube it. 125, thank you. X minus 2 equals 125, easy. Add your 2 over, x is 127. Okay. And so using your reciprocal exponent is going to cancel it out and allow you to solve. It's a little lost. All right. So the reason we have to look for a second answer here is because when I was doing this right here, this step right here, I had a variable involved, right? I have a variable involved when I'm taking the root. Now, remember we talked about if I just say, what's the square root of 25? With no variable involved, you're going to assume principal root, okay? But when you have a variable involved, you then have to look for a second answer because we have a variable that's going to equal the square root, all right? If it were cubed root, I wouldn't have to worry about this because I don't have two different potential answers with a cubed root. I only have one principal. But when I have an even root, two things could equal it, right? Two things can equal the square root of 25 here. The first thing that it can equal is positive 5, right? Now, the other thing is if this were to an even power, it also wouldn't matter because it's always going to be positive. But when I have it to a cubed power, a negative is going to make a difference, right? And so when you're doing this feature here with an even index, I have to consider the negative root of that guy, the negative root of him. Make sense? So when you have a variable involved and an even index, you have a positive and negative root possible, Now, when we check it, it's going to be a little bit different with our extraneous solutions, but you have two possibilities when you have an even index, all right? And so what is negative 5 cubed? Well, that's going to give me negative 125. And then what's going to happen here? Yeah, negative 123. All right? And so you can look at both of those. They will work because you have a cubed root. You have a cubed root originally. All right? Makes sense? If I take negative 123 minus 2, I can do a cubed root of negative 125. I can square it, and it will work for both of these. All right. So notice the difference here. In the ones that we have been doing, we're at the top of page 387. In the ones that we have been doing, we have had all of our variables inside the radical. Okay? We've had all of our variables inside the radical, which means that we really didn't have a position for a potential extraneous solution. Your extraneous solutions will show up when you have a variable on the outside, all right? Because what you're going to create is you're going to create actually a quadratic, and you're going to have two possible answers automatically, and then you have to plug them back in to see if they work. So let's look at this one. Again, we want the radical by itself, even though the other side's not going to be isolated when we do that. So we are still going to take this problem and we are going to subtract that 5 over as our first step. So we end up with the square root of x minus 3 equals x minus 5. Now when we square it, my radical still goes away. But what happens over here? What do I need to do there? Yeah, I have x minus 5, x minus 5. I have to FOIL there. Now, it's a perfect square trinomial. So it's going to end up being x squared minus 10x plus 25 when you FOIL it. But you have to FOIL it. It is x minus 5 times x minus 5. Do not just square the x and square the 5. That is the most common mistake that people make when they do this, okay? Do not just square the first and last. You must FOIL it. You will have a middle term for a perfect square trinomial. All right? This is not conjugates. You'll have a middle term. So how do I solve this then? Right, so I need to solve by factoring or by quadratic formula. Those are my options. So the first thing I'm going to do is I'm going to set it equal to 0 because either one of those options requires that it be set equal to 0. And then I want to see if I can factor it easily. If I can factor it, I'm just going to go that route. So I personally always keep my leading coefficient positive, which means I'm going to move everything to the right side of this equation just to keep my leading coefficient positive. So I'm going to subtract my x. Make sure you subtract it from the like term. I'm going to add my 3. So I'm going to get that x squared minus 11x plus 28 equals 0. That is very easily factorable, is it not? Yes, no, maybe? Yeah, factors of 28 that add up to 11 are 4 and 7. So I have x minus 4, x minus 7 equals 0. I have two possible answers here. What are they? 4 and 7. Positive 4, positive 7 here, okay? So my potential answers are x equals 4 and x equals 7. This little guy is very important. Check for extraneous solutions. We have to plug it back in and make sure they work, okay? Sometimes both of them will work. Sometimes one of them will work. Sometimes none of them will work, all right? So that is a possibility. It's possible you have two answers, one answer, no answer here, okay? Just because you solve for it does not mean it's going to work when you plug it back in. So let's look at this. Let's plug it back in and see what happens here. All right, so I have the square root of, I'm going to use 4 first. 4 minus 3 plus 5 equals 4. 4 minus 3 is 1. What is the square root of 1? Now, hang on, I'm going to say this. These are all numbers. I am just doing order of operations. There is no variable involved. So that means it is primary root only, okay? Primary root only. I do not consider the negative root when I have all numbers and no variable. So when you are plugging it back in, it is order of operations, primary roots, there's no variable involved. You don't consider the positive and negative root, okay? Number one mistake is people considering the positive and negative root here. You don't. So what is the square root of 1 when there is no variable involved? 1. It is just 1. So 1 plus 5 equals 4 is not true. That is not an answer. Had you considered the negative root, you would tell me that works. Does that make sense? All right. So 4 does not work here. Let's look at 7. We have the square root of 7 minus 3 plus 5 equals 7. 7 minus 3 is 4. Square root of 4 is 2. That works. All right. So my only answer here is x equals 7. That is my only answer. X equals 7. All right. These are fractional exponents. They just look like decimals, right? So they want to solve 2x plus 1 to the 0.5 minus 3x plus 4 to the 0.25 equals 0. So there are really two ways to do this. I turn them into fractions because my brain likes fractions more. And typically, you will, in this situation, you will prefer fractions. I know that's hard to believe because you will be able to see what you need to raise to the power easier often with fractions, all right? And I'm going to show you why. So when you have something like this, you definitely want to balance it, meaning you want one on one side and one on the other, okay? So I'm going to move over the easiest one, which is the one that's being subtracted, all right? So I am going to take this guy, this group, and I'm going to move him over. So I'm going to rewrite it to say 2x plus 1 And I am going to rewrite my exponents. What is 0.5 as a fraction? 1/2, right? And then when I move it over, it's going to be positive because it was a negative over here. So I have 3x plus 4. And what is 0.25 as a fraction? 1/4, all right? Now my goal is to get these out of fraction form. So I need to multiply something that both of those fractions will go away with. This is also called the common denominator. If you multiply by the common denominator, you will get rid of all of your denominators, right? This is why fractions are easier. Because oftentimes you'll look at 0.5 and you'll look at 0.25 and you're like, what do I need to multiply those by to make them whole numbers, right? And so it's easier in your brain because you've always had to do fractions with common denominators to put it in fraction form and just look for the common denominator. Raise both sides to the common denominator, okay? So I'm going to take both sides and I'm going to raise both sides to that 4, okay? Remember I multiply 1/2 times 4. This side is 2x plus 1 to what power? 2. This guy's easy. 1/4 and 4 is just going to cancel. I have 3x plus 4, which means on the left-hand side, I need to FOIL, right? So it's going to be a perfect square. So I'm going to say 4x squared plus 4x plus 1, 3x plus 4. And then I just need to get it equal to 0 and factor. Now this factoring is going to be a little more difficult because you do have to do a cross and factor by grouping if you don't see it immediately. But I am going to move these over. So I'm going to move the 3x and the 4 over. All right. I have 4x squared plus x minus 3 equals 0. All right. You need to factor that. So does everybody remember this factoring? Right? You can either say factors of 4 and factors of 3 and how they group up, or you can say 4 times 3 and factor by grouping. All right? So we could say 4 times 3, that's going to be 12. Factors of 12 that subtract to give me 1. Yeah, 4 and 3, right? So I'm going to say 4x squared. I need a positive 4x and a negative 3x, right? So just double check it by saying this is the same, yes, 4x squared. This guy is the same, yes, negative 3, right? And positive 4x and negative 3x equal 1x. That is the same polynomial. I just rewrote it to 4 terms. Everybody see that? Now I can factor by grouping. All right, so to factor by grouping, I group the first 2, and then I group the last 2. So if I group the first 2, we're good. I group the last 2, and I grouped behind a negative. What do I need to do? Change the last guy's sign. Okay? What can come out of the 4x squared and the 4x? 4x. And I'm left with? X plus 1. What can come out of the second group? 3. And I'm left with? That's how it should always work. So my grouping is 4x minus 3, x plus 1. My possible x's are 3/4 and negative 1. Yes, you have to check your 3/4. Okay? You do have to check for extraneous solutions here. You do want to check for extraneous solutions here. All right? So we are talking in the real number world here. We're going to plug in 3/4 and we're plugging negative 1. Back to our original equation. All right? So I'm going to say 2 times 3/4 plus 1 to the, I'm going to say 1/2 because that'll make more sense in our brains, minus 3 times 3/4 plus 4 to the 1/4 equals 0. All right? So far, so good. So I have 2 times 3/4. What is that? 6/4, also known as 3/2, right? So this is 3/2. I'm going to do it in a different color so you can see it. So we have 3/2 plus common denominator 2/2 gives us 5/2 raised to the 1/2. All right. Minus, we have 9/4 plus 16/4, right? Yes. That's 15/4, hopefully, to the 1/4. Equals 0. All right. And so this is what we're trying to figure out. Does it equal 0? Does it equal 0? All right. I will say 5 halves and 15, oh, did I say 15? That's 25, not 15.
Yeah,
25.
like-
And 25 fourths should look really similar. Why would they look similar? 5 halves and 25 fourths? I'm going to take my checking to the other page just so you can see it better. Why should that look familiar? Hang on, give me a second. All right. So if I rewrite this, I'm going to say 5 halves to the 1/2 minus 5 halves squared to the 1/4. Everybody see that? Everybody see that? How I could do that? I could just rewrite 25 fourths, 5 halves to the squared. So then I can simplify this guy. What do I do here? Power to a power, I multiply. So I get 5 halves to the 1/2 minus 5 halves to the 1/2 equals 0. Is that true? That is true. So my 3/4 worked. So my x equals 3/4 is an answer. I got a true statement when I did that. Does everybody see? I know the fractions are a pain and they're throwing you off a little, but you're just checking your numbers, okay? Let's check our 1. For 1, we would say 2 times 1 plus 1 to the 1/2 minus 3 times 1 plus 4 to the 1/2. All right, equals 0. So far, so good? All right, so 2 times 1 plus 1 is 3. It's -1, isn't it? No. It's 1/4, sorry. -1, -1. -3 plus 1 to the 1/2, right? And we have, no, -2. -3 plus 4 to the 1/4, all right? -1 to the 1/2 minus 1 to the 1/4. I have a problem. What's my problem? Square root of -1. We were talking about real numbers only. That's imaginary. Yes? Everybody agree? So that does not work. This is my only answer. All right? So if you get an imaginary number, not working, we have real numbers only. If you get it just not working in the answer, 7 equals 2, it's not an answer. All right? Check understanding number 5. This one's much easier, I promise.